But did they have to know what the volume of the remaining was? Yes?
I think actually do something like that once.
Okay, there you go. If you want to be on a reality show on TV that I've never seen, then that you could do that. I'm kind of proud that I've never seen it.
And if you want to turn your brain off when you watch something, just watch Lost.
Watch The Rock. It's awesome.
No, Lost.
Oh, Lost.
And I'll throw a pin at you.
I've never seen that show yet. All right. So guys, tell me, what was the definition of a pyramid? How did I create a pyramid? What did I do?
When all the corners of a shape...
All the corners come to one single point on the top. And actually that point, I sort of put it in the middle of the top, but it could be anywhere on the top. They can come together. You can have this pyramid that's leaning over. The leaning pyramid of whatever, right? Of Giza. Yeah, that would work pretty well. No. Sorry. So the way to make a pyramid out of this is this has infinite number of corners if you think about it, right? Circle. So I take all of them and I just take them to a single point. I've just made the shape of a cone, right? Or a teepee.
Or a hat.
Or a hat. A sorting hat. Sure, why not?
A dunce cap.
Dude, this list could go on. Let's not let that happen.
Wait, isn't that technically a pyramid, though?
Yes, beautiful. It is a pyramid. It's the simplest pyramid. It's got a circular base. We have other names for it. Just like, what's the perimeter of a circle? That sounds weird because we don't call it perimeter. We call it, what do we call the perimeter of a circle?
Circumference.
Circumference. All right, we got another name for it, but it means the same thing. Add up all the sides, but we call it a different thing because the circle, either it has infinite sides or it has no sides. Both of those viewpoints are correct. That'll freak you out for a while. So that's why we kind of give this another name. We don't call it a pyramid. We call it, in this case, a cone. Well, what's the volume of a cone then? What was the volume of this cylinder by itself? This is R. This is H. So what was the volume of the cylinder? Good. The air at the base, pi r squared, times H. I love it. So the volume of the cone, because it's a pyramid officially,
So it's a third of that?
1/3 pi r squared H. I like it. Kick ass. So again, if you see a cone sitting in the homework somewhere, I think they have one right above that last problem. Item number 22, 13, I can't remember which one I assigned, but that's how you do it. You just use this formula right there. So I wouldn't normally call a cone a pyramid, but now you know it fits the definition of pyramid. It is the simplest pyramid there is. Cool. Oh, there's a trough in there. I like it. Number 50. Aaron.
I have a question.
Yes.
I want to know what about cone for sphere. We can have cone for sphere, isn't it? If the base is a circle that has R, and we can have two cones.
Oh, sure, of course. Sure, if you look at a sphere and you say, okay, if I cut it across the middle, I could have one cone sitting there. One cone sitting there, sure. I mean, if you wanted to.
But I'd like to know for all the formula same, 1/3.
The formula ends up being the same because what I'm really, just because this, let me take this piece right here, let me take it out and put it right there. All right, that's that. Are you with me? So this piece here, this piece in the middle, I've just taken it out and put it there. So this could be part of a cylinder, right? And I can make the cylinder as tall as this radius is. That's going a little off script, but I like the question. Just because it was it started as a circle doesn't mean the cone's formula changes. I'm not sure how else to say that. Because any cone, when I make a cone, did I cut that out of a cylinder? No. But the formula for it will still be 1/3 pi r squared H. Because for any cone, there is this imaginary cylinder sitting around it that it is 1/3 of. I like it. Cool. I like it. Because thankfully they didn't build the pyramids by putting this ginormous rectangular block and then chiseling around. That would have been a very different experience.
Might have saved time.
Huh?
Could have saved time.
They could have done like an inverted pyramid. That would have been cool. And then it would have been wobbly in the wind. I don't know. But that's probably why they didn't do it. But yeah, so any shape, any pyramid that exists didn't have to be cut out of a block. It has the same formulas because it lives in like an imaginary shape like that. Yeah.
How do you think they built the pyramids? They're like the workaround gyres.
It's the aliens, dude.
No,
Yeah.
really. You don't like to speculate. Come on, you're a math guy, so
You didn't speculate, you just said aliens.
yeah. But ironically,
The answer is Jews, Egyptians, and Nubians. Pretty much.
I love you guys.
yeah. I mean, I'm not alluding to something like esoteric. I'm just saying, do you have any like real, speculation about like what kind of methods they would have used?
Not really. I haven't really thought about it in forever, to be honest.
You ever seen Speed with Keanu Reeves?
Speed, yes.
The Nubians weren't empire.
I'm not sure how that relates. This is I like that. Did you ever eat noodles on Friday night? It has nothing. Okay.
Have you?
Yeah. While I was watching Speed. All right. So what I want to do with chapter 11. So we're done with chapter 9. All right. So the area formulas, I'm going to require you to know some of them on the study day for the next test. We'll go over what exactly can be in your formula sheet. Right. Volume formulas, I'm going to let you have several of those written down, but I hope it makes sense. That idea that you don't need to know tons of volume formulas. You really just kind of need 2. So all I want to do in chapter 11, I was thinking about this earlier, I really kind of want to get into chapter 12 because that's where things get more interesting. Chapter 12 is all about probability. And probability is something that humans are not hardwired to understand. So people make mistakes all the time. My little brother, for example, he asked me if I still teach probability. He said, "Are you still teaching that there's like a 10% chance?" And I'm like, "Yeah, James, I am." And he said, "Dude, it's either going to happen or it ain't. It's always 50-50, man. It's always 50-50. So I said, "The probably it's going to snow tomorrow here in San Diego is 50%. Sure, it's going to happen or it ain't." I'm like, "Jim, I'm so happy you didn't become a doctor because those poor patients, doc, what's my chances? 50%, no." So I hopefully, I joke my little brother. He's actually pretty smart, but he was just giving me shit, I think. But we all understand that probabilities can be used.
How old is your little brother?
Oh, let's see. I'm 43. He's 41. 40. No, he's 39. 2 years between my sister and me, 4 years between me and my brother, 2 years between me and my
I'm thinking of this like 5-year-old.
I know. When I say little brother, funny thing is he's a little taller than me, and he's bigger than me in every way, basically. Yeah. So.
But you're smarter than him, right?
I don't know. He's pretty good. He's an engineer. He worked for the Army Corps of Engineers for a little while. So he's very hands-on, practical. I'm very theoretical. So.
Don't you know math to be an engineer?
What's up?
Don't you know math to be an engineer?
Not really. Depends on what you do. So he's not designing things, really. Yeah.
You ever seen Speed with Keanu Reeves?
Since you last asked me, I haven't seen it again.
No, has he? Your little
Oh,
brother?
has he? No. All right, so the only thing I want to do out of chapter 11 is, I think, 11.1.
You ever seen Bill and Ted?
I'm going to leave 11.2 and 11.3 for extra credit.
With Keanu Reeves?
Right? Guys, come on. So 11.1, one big reason why I'm okay with still doing this is because fewer and fewer people seem to understand percentages at all, which is troubling to me. Because everything we do is basically based on percentages. So like if somebody said, yesterday we took 10% off, today we're taking 20% off, so that's like 30% off right there. Well, that's bullshit, right? If anybody does not understand that, this is why I want to do section 11.1. Right? So let's say, give me a price that a shirt would start at. Give me a nice round number.
$19.95.
$20. Somebody understands round numbers. Let's say I take 10% off yesterday. So on Tuesday, I take 10% off.
$18.
How much will it cost now? Yeah, it's 20 minus 10% of 20. All right, let me stop there for a second. Is everybody able to do that level of percentage stuff? 10% off, so I do 10% of it and take it off. That makes sense. So 10% of 20 is 2, so I end up, now it's $18. It's $18, and it's not selling still, right? It's got, images of Nick Cage from The Rock. And they're like, why is this not selling? So the next day, Wednesday, they take 20% off.
$14.40.
I like it. So it starts off at 18.
Buy a lot of shirts, huh?
How would you set up that equation?
Well, first you would do 1/10 of 18 and then double that and then subtract.
Sure, I like it. So we can get into the estimation of percentages. That kicks ass. But to officially just set it up so you can throw in the old calculator, you want to take $18 and take 20% of itself off, right? So 20% off means 20% of what it is taken off of what it is. That's going to become important later when we do some backwards kind of stuff, figuring out percentages backwards. So this comes out to be 18 minus 360. So then you do end up with 1449. I like it. So let you guys think about this for a second. Don't say anything out loud. Try to figure out what the real percentage. Don't even suggest anything yet. It started at $20, right? It's now $14.40. So what was the real markdown? What was the real discount? Don't say anything out loud. Some of you guys are busted to say something. So let me ask you this real quick. How do you find the percentage of anything? If I wanted to find the percent of men in this room, what would I do?
Divide by 100 times.
No. Let's try this again.
Add up everybody in the room.
Good.
And divide by half.
Don't we keep going? Or-
Well, when
Yes.
you divide by 49%, since we know that the world population is...
No. I don't want a theoretical. If I said, guess how many men are in the next room, I would then have to use the fact that there's almost 50% of the world's population as men, right? But I want to know exactly what percentage in this room currently, right now, are men.
The men. We count how many men and women there are.
Good.
And then how many people there are in this room.
Good.
Divided by the men. No, I lost.
So if I want to know the percentage of blank, of something, let's say X, I would take the number of X divided by the total number. So if I knew the number of men and divide by the total number of people in here, that would be the percentage of men in this room. Now that basic concept is kind of going away. People are less and less able to do this. And percentages are actually a human conception. They're created by humans. When I do this, let's see, what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We got 21 people in here. And let's see, 1, 2, 3, 4, 5, 6, 7, 8. 8 of us are men. So what's that come out to?
8 over 20.
I totally made judgments based on your appearance. I'm sorry.
38.
But too bad. It just happened.
It's like half a person.
38.
What is it? 0.38?
Yeah.
0.38, and then we humans, we said, well, we don't like that freaking number. Let's make it. Let's multiply it by 100. Let's say it's always out of 100. So we completely, totally made this up. Math doesn't like this number. Math likes the real number. That's the real number. This is something so we can get a better feel of what's going on. If I said 0.002 of the, no, it's better if I say 0.2%. Your brain can kind of latch on. Oh, it's less than 1%. Your brain kind of can latch onto that and knows what to do with it. I like it. But I think part of it is percent does mean out of 100, and then some people think that means everything is out of 100. So if I said 38% of the people in the United States has something, owns hoverboard. Well, look at you guys. You immediately go morbid. And you tell me that's 38 out of 100, that there's 38 people. That's crazy. There's not 100 people in the United States. So that's how you construct any. So here I'm asking you, what was the percentage discounted off of 20? I want to know the percent change in the price.
28%.
So how'd you get there?
Well, instead of using the original number, I use it out of the 100, like you do percents. So if you're taking 10% off of 100, you're left with 90. 20% of that is 18. 18 from 100 is 80%. So then 10 plus 18 is 28%.
All right, let's do it a little bit easier way. So how much So if I want to find the percentage of men in this room, I do the total men divided by the total people. If I want to find the percentage change in a price, I do the change divided by the original price. It's sort of the same idea. Percentage blank, I always do the total blank divided by the original, the total amount, right? So how much did it change by? Total from 20 to 1440. 560, right?
Yeah.
And divided by 20.
20.
You get a number.
You do, it's crazy.
0.28.
Yeah, we do get 0.28. So 28%. I like it. So Matthew, I'm sorry to cut you off, buddy. Your method sounded like it probably was the right way. It's just not the most immediately, generally obvious way to go.
Yeah.
So a lot of the math that you're taught, what you really should do with it is make it your own. You should come up with a way that works. What's unfortunate is a lot of early math teachers are not flexible on what they take. I'm sure you guys have lived that experience. Where you have a method that works, and the teacher's like, that's not the way I taught it. Now, sometimes there's a reason to their madness. They want you to learn a certain way because it's going to help you out later, and they should explain that. But sometimes it's just completely arbitrary. And I hate that shit.
Do you think that's exclusive to math professors?
No, I didn't say that. I say from my own experience, I know this is true.
Could
Right?
be everyone but history professors that do that, hopefully.
Yeah.
So it would have been better for it to be 30, or to add the percentage instead of it being percent.
So that's the way they misrepresent it. They know that's better than what they actually did for the consumer, so that's the way they let the consumers think about it. They won't correct you if you say that. They're like, sure. Possibly. There's a lot of ways that you can manipulate people's understanding of percentages in your favor because fewer and fewer people understand percentages. So it's easy.
So you think that's a good deal for a shirt, or would you wait till like another?
Depends on what that shirt can do. Is it wrinkle free? Is it that? At Walmart, then that's not a good price.
No, not at all.
No.
I got 3 for 20.
I like it.
Just in case you didn't hear the first time. He got 3 for 20.
Tell us one more time when class done with stove, like 3 times, like these 3 shirts.
All right, guys. Hey.
What?
Hey. Shut up. Thank you. Thank you.
What percentage of our comments have been helpful?
Today,
Gotta take the total
about
amount of
0.
comments.
Okay, we're getting somewhere.
All right, so if I want to convert from decimal to percent, I already did that very quickly, and sometimes I assume everybody knows how to do it. So I want to make sure we're all on the same page. So if I want to convert from, let's say, decimal to percent. I want to show you something. Notice that this is in alphabetical order. Ooh, and I'm going to show you why I said that right now. So it's in D, and there's P, right? Decimal, percent. I'm waiting for something.
DP?
There it is, yeah. Got to get that out. So I just did it a second ago. If I had 0.12, how would I convert that to a percent?
Multiply by 100.
Yeah, exactly. Right? Because what does the percent symbol mean?
Out of 100.
Beautiful. So this kind of sucks that division out by 100 into that symbol. So if I want to go back this way, I actually do divide by 100. I love it. So notice that if you put this in alphabetical order, you go the direction that you want to change. If you want to go from decimal to percent, you move the decimal that way. Percent to decimal, you move the decimal that way. Kick ass. It's sort of like the idea behind the metric system, in a way, right? So what if I had 1.78? What would that be as a percentage? 178. So people sometimes freak out when it gets to be over 100%.
What do we do?
But 178% increase in profit, that can totally happen. What would 100% increase in profit mean? 100% increase. It doubles. So 178% is it almost
Triple.
Almost tripled. I like it. So because 200% would mean it would triple. How we doing so far? I like it. So that can totally exist in the real world in some situations. You can't have 178% of the people vote for Donald Trump, right?
Well, it might happen.
It could happen, but that would probably mean something went horribly wrong with the voting process. So what about this? What if I had that percent? What would that be as a decimal?
0.3%.
That is already a percentage. What would it be as a decimal?
Oh wait,
0.0000.
Yeah. If you want to go that way, you've got to move the decimal back. Right, so 0.000003. totally tricky, but yeah.
So it always moves two spaces?
Beautiful. Why? Because percentages are based on out of 100. When I multiply by 10, I move the decimal once. When I multiply by 100, I move it twice. When I divide, I move it back. So that's why we move it twice. The only problem is, which way do I go when? I really want... Exactly. It's grammatically perfect. Which way do I go when? I love that phrase. So this means 0.003 out of 100. So when I divide this by 100, it's going to get smaller. So then I move the decimal back. You guys. So let me bring fractions into the frame. That's too bad. So how would I convert, for example, let me start off nice. 3/20. How would I convert that to a decimal?
Times by 5? Oh, wait, no, never mind.
Yeah, you could. Totally.
Oh, yeah, that's it.
Why not? Decimal or percent. Percent is out of 100, right? So if I can make the fraction into out of 100, then the answer's staring me in the face. So if you multiply this by 5, you get
50%.
15 out of 100, which would be 15%. Which would be what decimal? How do you write 1500ths? 0.15. Kick yes. So the kind of problem I like to give you related to this section is this big chart, and it's got on the top fraction, decimal, percent, and then I have some spots filled and the other 2 spots empty. You just got to go from one spot to the next. Kick ass. I think the homework has something like that in it too. So what about this? Here's the last thing in this section. Notice the way I said that so people wouldn't start pecking up. I hate that there's so many ways shown to do this kind of problem. So let me see if you guys have a way you've been shown. If I said 8 is what percent of 11? I've seen some really weird-ass ways. The less weird-ass way is like is over of. Has anybody ever heard of that?
Yeah.
Even that is not the greatest way to do it. If you like that way, I'm not shitting on it. I'm just saying I don't think it's the best way to do it. There's a really weird-ass way. I can't even really totally remember it, where you do some weird stuff and you cover one of these and it's crap. I was amazed when I saw that. Algebra exists for a reason. Oh, shit, he said the A word. This is an algebraic equation read off. So let me just translate it back into algebra. There's a lot of translation in math. I got to go from English to mathish. So 8 is equals what percent? Don't know. X. Of
Division.
times, kick ass. Of, people don't know what of means anymore. It kills me. So when I'm talking about percentage of, fraction of means multiply. People used to just know that. They used to teach that. Now I think they stopped. Times 11. So then how do I solve for x? Divide by 11. So I get x equals whatever. And then whatever that is. I don't know. So we got that for me?
8/11.
Thanks, sir. This is not an eye test. What is it, sorry?
Was it 0.7?
That's true. 0.7, I like it. 0.7 something. Somebody had the calculator out earlier. 0.72. Okay. So then you can make that.
Percent.
Say again?
How do you get that to percent?
Aw, Garrett.
You moved the decimal.
Yeah.
So that was 72%.
Garrett's showing off his jackass skills. 72%.
I always knew you had that.
Kick ass. So, anytime you can phrase a percentage question like this, you can just translate it directly into an equation, right? So if I said 200 is 13.2% of what? Do that one real quick. So obviously, if you don't have a calculator, this gets a little bit challenging. I would not want to do that long division. So how do you set up the equation?
200 equals. What do you want it in the decimal?
Yeah, good. Point.
0.132.
And it's not me that wants it. Math wants the actual number. This is something we did so it makes more sense to us. We got to put it back into a number when I do math with it. Of what? So of x, kick ass. And then just divide by 0.132. Cool.
Is that some like significant number?
What's that?
Because it's 151515.
Is it? No,
Yeah.
I just totally made this stuff up. Sometimes they get weird ass results. Oh well.
1515.15.
That's awesome. I wish I could take credit for that, but I can't, to be honest. I should have said, well, yes. But
Answer to
no.
life.
What's up?
The answer to life.
Yeah. It's the alternate answer. I like that. 42 is basic level shit.
Yeah, for real, right?
All right. So let me get one little thing. So that's section 11.1. That's all I want to do from chapter 11. 11.2, 11.3, if you want to, you can do it for extra credit. So one little step into chapter 12. Have any of you ever heard of the Monty Hall problem?
Monty Hall?
Monty Hall. This is a long time ago. Do you know that show, Let's Make a Deal?
Yeah.
I think Wayne Brady was hosting it most recently.
Yeah.
Is that
The one at the end when they have 3 doors, right?
Oh, yeah.
All right, so just bear with me for a second. You start with 3. The way it used to be, there was this guy named Monty Hall, total game show type, and game show host, and he hosted the show, and at the end of the show, there would be 3 doors. So this one person that was the big winner of the day, they would get to pick one door. And behind 2 of the doors are goats, for example, or something the contestant doesn't want. If they want goats, then that would be a bad example, right? But, I got the goat. I don't want some stupid boats. I want the goat. So,
What are you going to do with a boat?
exactly.
working?
Unless you have a goat already, you can put it in the boat. So 2 of the doors have goats, and one of them has this big prize, like a trip or a boat or a car or whatever. This confuses the hell out of people. And this is a really good illustration of how probability is not hardwired into our being. It just isn't. And that's why some people don't trust it. But it exists and it works. If you pick a door, so pick a door.
3.
All right, 3. 3 is the first one. And so you picked the door 3. You picked 3. What's the probability that you just picked the winning door? The door that's got the good prize?
1 out of 3.
1 out of 3. Cool. Is everybody cool with that? That's the basic probability is just 3 chances, 3 different things. I picked one of them. There's a 1/3 chance I picked a certain thing. Yes?
I just read another article about this thing, but they use jelly beans instead.
All right, I like it. Has anyone ever watched the show Mythbusters?
Yes.
Yeah.
I know it just recently ended. But they did like a whole setup. They experimented and they studied and they actually showed that you get the results that we're about to get. So right now, if you pick door number 3, the probability that you have picked the right door at the moment is 1/3.
Okay.
That's pretty good.
I like it. Which means, so how often would you? What's the probability that it's a goat then?
2 out of 3.
Oh, got
2 out of 3.
goat. Sorry, I was just making fun of my inability to spell the word goat. So the 2/3 of the time you would have actually picked a goat. So what I'm going to do, what always happened was the host opens a door. So what's most likely right now? What's most likely the truth?
You gotta go.
You got a goat.
Okay.
Only 1/3 of the time will you have won straight off. So most likely there's a little goat, little mutant goat, waiting for you to take it home. It's actually got its whole head turned around like an owl. All right. It looks more like a spider, a goat spider. So now watch. If that is true, and it's only 1/3 of the time that's not true. Are you guys with me so far? Only 1/3. 2/3 of the time, twice as often, it's a goat. The host is going to open another door and ask if you want to change. Now the prize is behind. Let's say the prize is behind door number 1. Well, which door is he going to open?
2.
Door number 2. So this scenario is true 2/3 of the time. You guys with me? So he's going to open this door, of course, and show you that it's the other goat, the other, spider goat. Let me just make it more spider-like. Okay. So should you switch doors?
Yes.
Yes, you should. Even, because only 1/3 of the time you would have picked the prize. So how often is it better to switch doors? 2/3 of the freaking time. Now, people say, the minute he opens that door and shows you a goat, people say, well, now it's 50-50.
It's not.
And you can see why people would think that, but of course it ain't. Why did he open that door? Because he can't open the door with the prize behind it. So 2/3 of the time, he's got to open the door that's loser, so you should switch. Now, does that mean you will definitely win?
No.
That's the mistake people make. Probability never says this will definitely, even if there's only a 0.1% chance of you not winning, you could not win.
Wait.
Right? That's what that means.
He gives you a chance to open either doors?
He chooses a door. Now, at the beginning, he says choose a door. We chose door number 3.
But you've opened it. You've seen it's
We
not
haven't
it.
seen
No, we don't know yet. Nothing's been opened yet.
Okay.
I'm just saying that 2/3 of the time there will be a goat. We don't know yet. He gives us a chance to switch when he opens the door and shows us another goat. He says, do you want to switch?